We're going to basically be taking a look at this learning packet here. And the goal is to actually solve all the problems that we possibly can. And the first thing I recommend you do is just go through, get all these formulas memorized here in the key equations. And of course, not only do you have to memorize the key equations, but when you look here, these three equations here are also three equations you should memorize. So you want to memorize all the stuff here and all the stuff here. And actually, I've restated this key equations below, and of course, knowing how to convert these things into their proper sine and cosine components is also really a huge thing that you're going to need to know how to do, so make sure you get that done too. So again, all this and this is really key to getting this learned. So you should definitely, it's just got to get done. So a lot of key concepts, a lot of ideas, so let's just jump in and get into this learning packet. So first of all, determine which of the following is projectile motion. So I just want to kind of go through and just get this here. So jet airplane during take. So remember, projectile motion means that gravity is the only means of acceleration. So a jet airplane, well, it's going to have to accelerate to take off. So that rules out A. Baseball during Barry Bonds, home run. You know what? We're going to say no because air resistance actually affects this thing. Spacecraft, after all the rockets turn off, in Earth orbit. That can be a tricky one, but we're really, really far out in space, and so we're not going to use the projectile motion model. Now, this, yes. This, yes. This one, it depends. It might be a maybe. And then definitely G. So I would actually take yes or no for this one. It really depends on what model you want to use, because the rocket may be accelerating or not. Anyway, so there we go. No. Question number 2. Decide if each statement below is true or false and explain your reasoning. So, at a projectile's highest point, its velocity is 0. False. Because v naught x is not equal to 0. So when you launch a projectile in the air, it goes into the air and then it lands. Well, yes, here, when it starts off, you've got, at an angle theta, you've got v naught as its speed. But then when it actually reaches the top here, yes, Vy equals 0, but V naught x remains unchanged. Now, at a projectile's highest point, its acceleration is 0, also false. A in the x direction is 0, because it's always 0. But A in the y direction remains negative g. Now, the rate of change of the x position is changing with time along the projectile path. It's a deep way of saying, is it accelerating? And the answer is no, it's not accelerating. No, because ax equals 0. And here, yes, ay is negative g. So this is really not the kind of thing you would see on the exam. So I'm just going to put a little blue mark here and here and say too hard. So if you got this, you're awesome. You know your calc stuff. If you didn't, don't worry about it for the exam. It's a little bit too hard. So, suppose the hunter fires his gun. Suppose as well as the bullet flies out horizontally and undergoes projectile motion. The shell for the bullet falls directly down. Then the shell hits the ground before the bullet. This is interesting. This is actually false. This is just like that lab we did where we had something. We had two spheres and one fell this way and the other dropped straight down. And if you noticed in the video that we analyzed, they actually hit the ground at the same time. So this is actually false. They both fall with the same acceleration equal to negative g from the same height. So that's kind of sad. There we go. All right. Now, we have a soccer ball going in projectile motion, so it's going in the air. We want to know some things about the highest point of its flight. So, at the highest point in flight, let's just be clear on some choices we can eliminate. First of all, we can eliminate A and B right away. Let me tell you why. Okay. AY is always negative G. So now here. We can rule, so we have C, D, and E. So if you're going to guess, I'd want to guess between C, D, and E because A and B are totally false. Now here, for choice C, D, and E, one other thing we need to realize is that Vx is never 0. It's always equal to V naught x. So if you're launching at an angle theta and you have a speed v naught x is always equal to v naught cosine theta. Okay, so that means that's going to rule out c and e, and that leaves us choice D. When we look, yes, vx is greater than 0, vy does equal 0, ax is 0, and ai equals negative 9.8 meters per second squared. So you should actually memorize this. This is everything that happens at the top of an object's flame. And then finally, a hunter with a gun is preparing to shoot a monkey hanging from the tree. We actually eliminated this one. We're actually not going to be doing this one. So this isn't a more advanced physics class. This is something I might give my AP class. So we don't do this one. Now, here we go. Question number 5. You are riding your bike in a straight line with a speed of 10 meters per second. You accidentally drop your calculator out of your backpack from a height of 2 meters above the ground. When it hits the ground, where is the calculator in relation to your backpack? This is just like that skateboard problem we did. We had a skater on a skateboard, and they threw something up into the air, and actually what ended up happening was the object landed back in their hand. So when they throw something up in the air, it goes up in the air and it actually lands back in their hand. So in other words, you and the backpack are directly above the calculator, and that's something we did before. Okay, now here, this is a really good question to kind of study and get a feel for. So it says, a ball of mass m is moving horizontally with a speed v naught off a cliff of height h is shown. How much time does it take for the rock to travel from the edge of the cliff to the ground? Let's actually get this one. So we have our formula is y equals a negative 1/2 gt squared plus v naught yt plus y naught. And we also have x equals v naught xt plus x naught. Now we want to know the hang time. And so what we could say is, here, let's just kind of remember some things. V naught y is 0. This is all horizontal. It doesn't affect the y motion, and that's something we discovered again from the lab, where we dropped something and we fired something horizontally, and the fact that it had horizontal speed had no impact on the time that it takes to reach the ground. So y naught is going to be equal to h. So now what we're going to end y at the bottom is 0. So this is h at the top and 0 at the bottom. So let's go ahead and actually solve. So we're going to have 0 equals 1/2 times g times t squared plus h. Sorry, this is negative 1/2 plus h. So then we end up getting here negative h equals negative 1/2 gt squared. So we have 2h over g equals t squared. We take a square root, and so we end up getting choice E. This is wonderful. So now here, this is just great. So find the missing legs or angles of the triangle shown. This is just a great way to kind of practice. So what we're going to say is we're going to use SOHCAHTOA. So let me just draw up a little SOHCAHTOA triangle so we have this all set. This is so beautiful. So we have hypotenuse, opposite, adjacent. We have SOHCAHTOA. This is just beautiful. Can't believe my luck. To get to do some SOHCAHTOA today. I'm just really grateful. So 12 over d equals cosine of 20 using SOHCAHTOA. So that means d is 12 divided by cosine of 20. I don't even know what that number is, and I'm not even going to bother to find it. Now Vy. I'm just going to tell you right now, that is 26 meters per second. And the reason I know that is for you trig stud muffins out there. I know that Vy is going to be V sine of 30. And that's 52 times a half when I actually plug that into my calculator. So that works out to be 26. And then when I want to get Vx, that's going to be 52 times the cosine of 30. So when I actually plug that into my calculator, let's go ahead and do that. And I end up getting 45.03 meters per second, which is wonderful. Now here, we want to get this angle, so we got to be careful here. I wonder if there's a way to kind of flip this. I'm gonna try this. I was hoping I could like flip the triangle, but that's not gonna work. Is there like a paste special function? No, let's see. Let's see if we can paste it special. Paste above, paste image as. It doesn't work. Okay, no problem. So here's the deal. We're going to actually have to flip this in our minds. What we realized is that theta is going to be the inverse tangent of 12 over 14, which I'm not even going to bother to get. And then here, V is going to be 12 squared plus 8 squared, which ends up being, let's see, so this has a length of, this is 2 times 4, and this ends up being 3 times 4, so not very helpful. 144 plus 64, so it's going to be square root of 208. So when we actually get that number, that actually works out to 14.42. And then, of course, to get the angle, we're going to do the inverse tangent of 12 divided by 14, which I'll let you kind of check. So I'm not going to work these out just because I want to make sure we get through as many problems as possible. Now, this is great. This is actually a really good exercise here, right? And I'm actually going to go ahead and draw the components of the acceleration as well. So I'm going to draw AX and AY as well, just so you really get a feel for this problem. And actually, that'll be a really good point to pick up in the next video.